Hello viewers, in today's class we are going to discuss these two important integrals, right? And here in this lecture we are not going to solve these two integrals using the usual method, right? Although these two integrals can also be solved using the method of partial fractions, but here we'll try to find out the values of these two integrals by making use of a direct result, right? So let us start. Now see, in the first integral, we have the limits from 0 to infinity, right? And in the second integral, the limits are from minus infinity to infinity, right? And if we see the integrand, in the first integral, we have x square over x square plus 1, x square plus 4, and x square plus 9. And in the second integral, the integrand is same as the first integral, but here we have x square divided by x square plus 1, x square plus 2, and x square plus 3, right? So the special thing about these two integrals is that in the numerator we have the term x square, right? And here also we have x square, and in the denominator we have the product of three terms, right, containing x square, right? See, here we have x square, here also we have x square, and here we have x square. And similarly, here we have x square, here we have x square, and here also we have x square, right? And then we have these numbers. Here we have 1, 4, and 9, and here we have 1, 2, and 3, right? And the numerator is x square, and here also we have x square, right? So what we will do in order to find out the values of these two integrals, we'll first write the general integral, right? Now see, if we write the general integral, then we have 0 to infinity, and we have x square divided by x square plus a square, and here we have x square plus b square, and here we have x square plus c square, right? And here we have dx. So when we come across with these type of integrals, then the direct value of this type of integral is given by pi divided by, here we'll write 2. So in the numerator we have pi, and in the denominator we'll first write 2, and then we'll write here the three terms containing a and b, that is a plus b, then we have b plus c, and then we have c plus a, right? So we'll write the denominator as a product of 2 times a plus b, b plus c, and c plus a. So here a and b and c, they appear in the cyclic order, right? So the value of this integral is pi divided by 2 times a plus b, then b plus c, and then c plus a, right? So now if we compare this integral with this one, we can easily find out the value of this integral. So now if we compare this integral with this one, and then see, here we have a square. So a square is 1, then b square is 4, and c square is 9, right? So from here we have a is equal to 1, b is 2, and c is 3, right? So the value of this integral is equal to pi divided by 2 times a plus b, so we have 1 plus 2, then we have b plus c, that is 2 plus 3, and then we have c plus a, that is 3 plus 1, right? So we have pi divided by 2 times, here we have 3, then we have 5, and then we have 4, right? So this is pi divided by 120, right? Now let us find out the value of this integral. Now if we compare this integral with this one, the difference is that here we have the limit from 0 to infinity, right? And here we have the limits from minus infinity to infinity. So we'll first try to convert this integral into this form, that is will change the limits. So here we'll make use of one important property of definite integrals, and the property is integral from minus a to a f of x dx is equal to 2 times 0 to a f of x dx whenever f of x is an even function, right? So the meaning of even function is that if we replace x by minus x, then f of minus x must be equal to f of x, right? So here we have f of x is equal to x square divided by x square plus 1, x square plus 2, and x square plus 3, right? So if we replace here x by minus x, then we see that here we have x square, here we have x square, and x square, right? So when we replace x by minus x in this expression, we'll get f of minus x is equal to f of x. So this function is even function, right? So now this integral can be written as 2 times 0 to infinity, and we have x square divided by x square plus 1, then x square plus 2, and x square plus 3, right? So here we have dx. So now by using this property, we have converted this integral into this form, right? So here the limits was minus infinity to infinity. Here we have 0 to infinity, but extra factor of 2, right? So now this integral is similar to this one, right? So if we now compare this integral with this one, then see here we have a square. So a square is 1. Here we have 1. Then b square, this b square is equal to 2, and then c square is equal to 3, right? So from here a is 1, b is square root of 2, and c is square root of 3, right? So now the value of this integral, which is same as this one, is equal to, here we have 2, then the value of this integral is pi, and then we have here 2 and a plus b. So we have 1 plus square root of 2. Then we have b plus c. B plus c is square root of 2 plus square root of 3. And then c plus a. So c is the square root of 3 plus 1, right? So now this 2 and this 2 get cancelled. So we have pi divided by 1 plus square root of 2, square root of 2 plus square root of 3, and here we have square root of 3 plus 1, right? So the value of this integral is equal to this expression, right?